Hi guys, in this tutorial, I'm gonna solve question number 7. Paper 11 May 2012. The first two terms of an arithmetic progression are 1 and cosine squared. The first term is 1. Second term is cosine squared x. The first two terms of an arithmetic progression. Show that the sum of the first 10 can be expressed in the form of. First, to get, we have now a sequence. First term means we have value of A, which is 1, and have value of D, which is second minus first. So cosine squared x minus 1. It's given sum of the first 10. If you write the formula of summation of n over 2 is n is equal to n over 2, 2a plus n minus 1 times d. So n is 10 divided by 2, 2a, which is 2 times 1, plus n minus 1, 10 minus 1 is 9, times d, where is d is cosine squared x minus 1. If you expand and get S10 is equal, 10 divided by 2 is 5, 2 times 1 is 10, 9 cosine squared x, 9 by 1 is 9. Simplify, 5 times 2 is 10, simplify 5 by 9 is 45, or if you simplify 9 with negative 9 first, will be negative 7, 5 by 9 is 45, cosine squared x and 35, if you expand. He asked in this equation to show that it's a minus b sine squared. After simplifying and get the answer in terms of cosine, but you can remove cosine and write it in terms of sine, 45, 1 minus sine squared x minus 35, simplify is 45, simplify 45, sine squared x minus 35. If you simplify 45 minus 35, so the answer will be 10. 10 minus 45 multiplied by sine squared x. This is S10. Ask it to show that you can write the sum of the first 10 terms in this form. Part B. The first two terms of geometric progression 1 and. The first term is 1. Second term is third tan squared theta. Find the set of values of theta for which the progression is convergent. Convergent means are between negative 1 and 1. So the first two terms are given, so A is equal to 1 and R is equal to third tan squared theta, because if you divide U2 by U1 will be third tan squared theta. So this is A and R. The first two terms of geometric progression are 1 and third tan squared theta, where is theta between 0 and half pi. Find the set of values of theta. Ask to get the set of values of theta for which the progression is convergent. If you remove R now, it's a third tan squared theta. Have to be between negative 1 and 1. But because this is tan squared, so the value of squared have to be positive. So this means third tan squared theta between 0 and 1. So tan squared theta between 0 and 3. If you multiply both by 3, so tan squared theta between 0 and 3 By solving the quadratic equation, if say tan theta, by taking a square root for both sides, so tan theta may be 0 or maybe 3 to get the range in between. Shift tan, you can get theta, which is shift tan will be 0, and shift tan for 3, you can write your answer. He asked to show, find the set of values of theta, tan minus 1 for 3, tan minus 1 for 3. Sorry, for root 3. This is by taking the square root after taking the square root will be 3. Shift tan for root 3. Shift tan for root 3. You can get the exact value of theta will be pi over 3. So the final answer is theta between 0 and pi over 3. This is the range of theta to be convergent. In part 2, find the exact value of the sum to infinity when theta is equal to 1 over 6 pi. We already have now again a is 1 and r is third tan squared theta. So r is equal third tan squared theta is 1 over 6 pi. Simplify and get the value of r. Or you can keep it and use sum to infinity is equal to a over 1 minus r, 1 minus r. So the a, which is 1, divided by 1 minus r, which is third, then tan squared 1 over 6 pi. You can use your calculator to simplify and get sine alpha, the exact value. You will get it 9 over 8. Or you can round your answer to a significant figure. It's written here exact. So keep answer as a fraction, but in this case, because 9 divided by 8 is 1 and 125. So if it is exact, you can write it. If it is not exact, so please keep it as a fraction. That's it. Thank you.